So we are going to talk about the area of regular polygons. This is the most difficult of the areas because it's terminology that you haven't seen before, and you have to recall to your memory either special right triangles or SOHCAHTOA. And so the formula itself is not difficult, but just knowing the terminology because it's new. Area of a regular polygon. So they give you a sample of a regular polygon, and they give it actually inscribed in a circle here, because there's two terms that we're going to refer to when we're talking about polygons. The first one is one that you're familiar with, which is radius. The radius goes from the center to a vertex, okay, from the center to a vertex. And that they show it to you in a circle so that you see why it's called a radius of the polygon, right? If this were inscribed in a circle, it would be the radius of the circle. Then you have the new term, which is called an apothem. An apothem goes from the center of your polygon, and it goes perpendicular to the side, okay? Perpendicular to the side. And so you are going to use this to calculate things. Something you need to know about this is an isosceles triangle here. It's technically, yeah, it should be an isosceles triangle. But when you have a perpendicular, it actually cuts this side of the polygon at its midpoint, all right? So that's important to know as well, because you're going to use the fact that it cuts it in half when you start doing some of this stuff with it, all right? So the apothem is the new term, and that is this line right here that is perpendicular to your side, and it cuts the side that it touches in half, all right? So we have, it hits at the midpoint there. It's a bisector of it, all right? And so the formula for calculating the area is 1/2 the perimeter of the polygon. That's what the P stands for here. And you multiply it by the apothem. So 1/2 the perimeter times the apothem. So you need both of those to calculate the area of a regular polygon. And so there are going to be times when they give you one of these lengths, and you have to use either SOHCAHTOA or special right triangles to figure out the other lengths that you need. All right. And so that's really the most difficult piece of these, is using the information you have to get what you need. All right. So let's look at the first example. Top of page 611. Find the area of the regular pentagon with a perimeter of 40 centimeters. All right. Perimeter of 40 centimeters. So they have told us the perimeter. We know that in order to solve for this, we have to have not only the perimeter, but also the apothem. All right. If they've given me the perimeter, they have basically told me the side lengths. What are the side lengths of this if this is a regular polygon and my perimeter is 40 and I have 5 sides? It's going to be 8. So that means each length here is going to be 8. That means this length right here is going to be 4, because that apothem should cut it in half. All right. It also cuts the angles in half. So you have to recall to your memory interior angles. All right. If I were to look at a pentagon and think about the interior angles, how would I know what those interior angles are? So if you're using 360, which angle am I trying to find? Okay, so let's talk about it. You can either find one of these angles here, all right, and that would be half, that would be cut in half right there. Yeah. Or you can find one of these angles, which would also be cut in half, all right? If you find the interior angle here, this one, that's going to be 360 divided by 5, okay? If you find this angle right here, you're going to have to do the sum of the angles divided by 5, n minus 1 times 180 divided by 5. Remember that? You take your sides, subtract 1, multiply by 180, and divide that by 5, okay? So it depends on which one you're solving for. If you always solve for the inside one, that's perfectly fine if you want to remember your 360, but you have to remember those are both cut in half, all right? So if I take 360 and I divide it by 5, what do I get? 72, all right? So that means that I have found this entire angle as 72. I don't want the entire angle. I'm trying to find a side length here. So I just need this piece of it. So what is this piece going to be if the whole thing is 72? 36, okay? So if you always use 360, that's fine. Just recall that you're cutting those in half. And if you use the 180 times n minus 1, you're also cutting that in half, all right? So I'm going to pull this triangle out here so that we can just look at it separately. So I have this triangle right here, and I know one side length and I know one angle, correct? All right, so how do I find? I am looking for the side length that is the apothem, which is this one right here, perpendicular, yes? I have this side length here, and I have this angle measurement here.
You can use tangent.
Yes, I can use tangent. From this angle, this is opposite, this is adjacent, and I can use my tangent. All right? So the tangent of 36 should equal opposite over adjacent. And then how do I put that into my calculator?
You're going to divide by
4 divided by tangent of 36. Make sure you are in degrees, not in radians, and then calculate what that would be. 5.5. And that's rounded, of course, to 1 decimal place. So I have solved for this side right here, which is my apothem. 5.5. All right. So now I have my perimeter that was given to me. I have my apothem, 5.5. I have everything I need to plug this in and solve for my area. So my area is going to be 1/2 my perimeter times my apothem. All right, which is going to be 110. All right, let's go over these. A regular hexagon with a perimeter of 42 yards. You should have gotten 127.3 square yards. And then a regular nonagon of with a perimeter of 108 meters. You should have gotten 890.2. All right, so let's look at the first one. How many sides does a hexagon have?
6.
6. So I'm going to take 360 divided by 6, which gives me what type of angle? 60, but I need to do what with that?
You divide by 2.
Cut it in half. So I'm going to have a 30-degree angle when I have this triangle here. All right, so that's going to be my 30-degree angle. All right, they've given me the perimeter as well, right? Perimeter is 42, so I need to take that and do what with it? Divide by 6, which is going to be me 7, but that's the entire side length. So what is this piece going to be? 3.5. All right. So if I want to solve for this one, I'm going to say the tangent of 30 degrees equals 3.5 over my apothem, which is what I'm looking for. And so in your calculators, you would say 3.5 divided by tangent of 30 is my apothem. All right. And you can actually do the whole thing. You can say the area is going to be 1/2 my perimeter, which is 42, times my apothem.
I put 48. I get everything else.
Second one, how many sides does a nonagon have?
A 9.
So I have 360 divided by 9, which gives me what type of angle?
1. Oh, yeah, I got that.
And then divide that by 2, so it's going to be 20, right? So my triangle is going to look like this. I have a 20-degree angle here with 108 perimeter. I need to take that and I divide by what?
Oh, I didn't divide by 2.
Divide by 9, right? So what's each side length?
12.
12, which is the whole thing. So I need to make that a 6. So for this one, the area is going to be 1/2 my perimeter. And my apothem for this one is going to be 6 divided by the tangent of 20. If a circle has an area A square units and a radius of r units, then A equals pi r squared. Pi r squared is your formula for a circle, all right? Do not confuse it with your circumference, 2 pi r. It is pi r squared. Pi r squared, you only use your radius for area. Unlike circumference, you can use that diameter because it's just 2r. But you need your radius when you talk about the area of a circle. All right, first example, example 2. Cater has a 48-inch diameter table that is 34 inches tall. She wants a tablecloth that will touch the floor. Find the area of the tablecloth in square yards. So we need the radius of the entire thing. If the diameter is 48 of that inner circle, the radius is going to be what? 24, right? And then I need to know the radius of the entire tablecloth. What am I going to do to find that?
24.
Yeah, so it's going to be 58, right? So the area then is going to be pi 58 squared, which is a big area there. Square inches. They did want it in square yards. It said in square yards. So if I have it in square inches, how do I divide to get, or how do I do this to convert to square yards? This way, this is inches squared. So you technically have 10,568.3 inches. So I have to actually convert it twice, right? Does that make sense? If it's square, you have to convert it twice.
Wait.
It's square, inches by inches squared. That's what squared means, right? And so you have to do that conversion twice, not just once. So you have to use that 36 twice. Divide by 36 twice, or 36 squared. When you do that conversion, you get 8.2 square yards. Because remember, in area, you have 2 dimensions. All right, so they just want the shaded region, which is the circle subtracted out the triangle. All right, so I have to actually find both areas and just subtract here. The circle is very simple, right? I have pi r squared. So if I was finding the circle here, I'm just going to say pi times 4 squared. That's the area of my circle. That's easy. But then I need to consider the fact that I have a triangle. And there's 2 ways to do a triangle, right? 1/2 base times height. I have neither, by the way. I don't have a base or a height here, okay? Or I can do 1/2 my perimeter times the apothem, okay? So 2 things you can do to figure out doing the area of a triangle. So if you're doing a triangle, you're going to create that apothem there, which comes straight down, and this will help give you your side length. Now, I will say that once you have your apothem, you now have your base and height. You can pretty much find your base and height and still do it 1/2 base times height, whichever is easiest at this point to do it. All right, so, but you have a triangle. So what are you going to divide by with a triangle?
360.
You can do 360, or that's 120, and that's going to be a 60 degree. You can use SOHCAHTOA here, or you can use your special right triangles. And I think they use special right triangles is what they did here. All right, so if I did 360, it's going to be 120, right? And then that's going to be a 60 degree angle up here at the top. That's going to be 60 degrees. And I have a special right triangle with a hypotenuse of 4. A special right triangle with a hypotenuse of 4, which is going to give me an apothem of 2. A apothem of 2 here, and a side length of 2 squared to 2. Does that make sense? And so you can do a height then. Your height would be another radius, which is 4. So your total height here would be 6. Make sense? We found the apothem, which is just the little piece down. They gave us the radius, and all of your radii are going to be the same, 4. So the 2 and the 4 is 6. So you have your height. Your base is going to be 2 of these. So I have 1 of them. 2 of them is going to be 4 squared to 3. So if I doubled 2 squared to 3, I would get 4 squared to 3. So my base would be 4 squared to 3. And I can use my 1/2 base times height there. That's one way to do it. Perimeter is going to be a little more difficult, I think, than just doing base times height. But if you want it, if it wasn't where you had a square to 2 or something like that, then you could do perimeter as well. And you could multiply that times 3 and do 1/2 apothem times perimeter. But this is going to be the area of your triangle. So you're going to have used the same method that we did before with a special right triangle or with SOHCAHTOA to find your side length of your triangle as well. So 1/2 base times height, or you can do 1/2 apothem times perimeter.
How did you find
Use my special right triangles to find my 2 square root of 2. Special right triangles. So in this case, the short side, hang on, let me draw it where it actually looks like the short side. The short side is your apothem, which before it wasn't. This is 4, this is 2, this is 2 square root of 3. And then that's only half of my side length. So I have to actually double that, 4 square root of 3.
I think you just wrote 2 square root of 2 above the triangle.
Oh, gotcha. Yeah, that's supposed to be a 3 right there.
Yeah.
Sorry, that's supposed to be a 3.
Okay, so wait, why does it become 4 square root of 3? Because
You double it. So when you double something like this, you just multiply the outside guy.
Right, okay.
That's how you double it.
I didn't know how we were going from square root of 2 to square root of 3.
I wrote 2 instead of 3. That's how we did that.
I thought I was just.
No. And then when you ask, I saw my 2 and changed it, but it was right the first time. So this is my circle. This is my triangle. Subtract. You're going to have to use your same method to calculate your polygon on the inside and pi r squared to calculate your circle on the outside. So I calculated the 2, which is the apothem, right?
Oh, I'm so. Okay,
They gave me the 4, which is the radius, and I just added those 2 to get 6.
Okay.
Talk through it. This is your radius right here that they gave you, all right? You're going to calculate your apothem. Your apothem will be the rest of your radius, and you're going to calculate half of your side length, which you have to double, and then you'll have your base times your height, okay? But you have to use your special right triangles to do that, or SOHCAHTOA, one or the other. You have to do one or the other.